Hello, welcome. Let's look at these Jamb past questions, Physics 2018. Question number 1. A man walks 1 kilometer due east, then 1 kilometer due north. His displacement is A. Root 2 kilometer north 45 degrees east. B. 1 kilometer north 30 degrees east. C. 1 kilometer north 15 degrees east. D. Root 2 kilometer north 60 degrees east. So how do we go about solving this? Now, for us to be able to solve this, we need to first of all identify where the man is walking from, because from the question we have a man walks 1 kilometer due east. So if we have this as the reference point, where this is north, this is west, this is east, and this is south. Now you have this man walking from here 1 kilometer east. This is east side, so he's going to walk straight down to this side 1 kilometer east. Then after walking 1 kilometer due east, he then walked 1 kilometer due north. So he's going to walk up north. This is direction of the north, because this is east, this is north, up north, and it walked how many? Also 1 kilometer north. So that is the movement. Then it is asking us the displacement. So we'll pick also the cardinal point, the reference point of this north. So he has moved from here down to this place. So what is the displacement? Displacement is the actual distance from where he started down to where he stopped. So this is the displacement D, also known as the resultant. Because this is the total distance, he can also take this straight to this point instead of walking 1 kilometer down here, then from here 1 kilometer here. So this D is what we are required to find. So how do we find this D? Now this D, which we also call displacement, we can also call it R, is actually equal to, if you are given a rectangle triangle like this, and you are given these two sides, and you want to find this side, you can simply say that this side is equal to the root of what you have here squared, which is 1 squared, plus what we have here squared, which is another 1 squared. And this will give us root of 1 squared is 1 plus 1 squared is 1. So this will give us root of 2. So that is the distance. So you have root 2 kilometers is the distance. But whenever you're talking about displacement, you need to check both the distance and the direction. So the direction here we can find using tan theta, and tan theta, if you have here as the theta, the tan of this is simply this over this. So the direction to the north, which we know is 1, all over the direction to the east, which we also know is 1. So you have 1 over 1. And if you want to make theta the subject of the formula, theta alone will now be equal to inverse tan of 1 over 1. And the inverse tan of 1 over 1 is what? 45 degrees. Now, having this as 45 degrees, how do you mention the direction? It's simply north first, north 45 degrees east, because it's going north. This is north, this is north, and this other direction is east. So if you are combining the whole thing, now you have 2 kilometers or root 2 kilometers north 45 degrees east. So this is the complete answer. Then why do we have this? Because we all know that displacement, from the definition of displacement is actually a vector quantity. That's why you must put both the direction and the magnitude. So displacement is a vector quantity which denotes direction, very very important, direction and size. Size in this case is the magnitude. So every vector quantity has these two important things. Whenever you say that something is a vector quantity, it must have direction and it must have size. So displacement is a vector quantity. Displacement is a vector quantity which denotes direction and size, which has direction and size. So this is the right answer. So after calculating this with this formula, then put the direction exactly the way I said it here. If it's south, then south has to come first before west. If it is north, north has to come before west. If it is northeast, north has to come before east. That's how you represent direction. Either the south or north must come first here before you have the other one. So from the options, we can see that option A is the right answer for this. Thank you. Hello, welcome. Let's look at this Jamb past question for physics 2018. Question number 2. The density of 400 cm3 of palm oil was 0.9 gram per cm3 before frying. If the density of the oil was 0.6 gram per cm3 after frying, assuming no loss of oil due to spilling, its new volume was A. 360 cm3, B. 600 cm3, C. 240 cm3, D. 800 cm3. So how do we go about solving this? Now, for us to solve this, we need to know the formula for density. So density is simply the ratio of mass all over volume. That is what density is. Now, we were told that there is no change in the mass. There is no loss of oil due to spillage. That means the mass remains constant. So for the first case, we have D1, which is the density here, to be equal to M1, which is the mass, all over V1, which is the volume. For the second case, we have D2, which is this density here, equal to M1, M2, which is also equal to M1, then V2, which is what you are calculating. But now from this, if we make M1 the subject of the formula, you have M1 to be equal to D1 times V1. Whereas from here, if you make M2 the subject, you have M2 equal to D2 times V2. But they say there is no loss of oil. This simply implies that M1 is equal to M2. So if M1 is equal to M2, that means that D1 V1 is equal to D2 V2. Now you know what D1 is, you know what V1 is, you know what D2 is, but you don't know what V2 is. So make V2 the subject. So we have V2 is equal to D1 V1 all over D2. So this is equal to D1 is what? We know that D1 is 0.9 times, what is V1? V1 is 400 all over, what is D2? D2 is 0.6. So if you press your calculator, or if you multiply 0.9 times 400 all over 0.6, then you should be able to get the right answer. And the right answer is 600 cm cubed. So that makes B the right option, 600 cm cubed. So notice we started from the formula for density. We made M the subject of the formula because they say there is no loss in mass. That means the 2M has to be equal. So we equated them. And the equation of this and this simply means that this is equal to this. So we equated them here and made V2 that we're looking for the subject. Then we get 600. That is how you go about solving equations as this. Thank you. Yes, let's look at this Jamb past question for physics 2018. Question number 3. Which of the following is true of an electric charge? A. Positive charge means deficit electrons. B. Negative charge means excess electrons. C. Electric current means movement of electrons. D. All of the above. Now, for us to understand this very well, we need to first of all understand what electric charge is, or what current electricity is. Current electricity. Now I'm going to start with this one. Current electricity is simply the flow of electrons or flow of charges. Flow of electrons. And we also know that electrons are charged or charges. They are charged negatively. Now, in an atom we have electrons and we have protons. The electrons are negatively charged and the protons are positively charged. So when you have excess of this electron that is negatively charged, you expect a negative charge. When this one is in excess, there has to be negative charge. Overall charge will be negative. But when these protons that are positive are in excess, then you expect it to be overall positive charge. When this one that is negative is excess, it will be negative. When it is not enough, when it is deficit, it will then be positive. So for this first statement, that positive charge means deficit electron, that is true. When there is less deficit of this electron that is negative, there will be more of this positive charge. So this is true. Then negative charge means excess electron. Of course, that is true. When there is plenty of these electrons that are negative, then it has to be negative charge overall. So this is true. Now electric current is the movement of electrons. From this other definition, this is true. So all of the above should be the general answer that is true. So that makes the answer to the question. So for electric charges, positive charge means deficit electrons, negative charge means excess electrons, electric current means movement of electrons. Then D, all of the above. All of the above is correct because all these three hold true for electric charge. So for electric charge, like I said, the electrons are negatively charged. So when they are in excess, you expect a negative charge. The protons are positively charged. So When the electrons are in excess, you expect a negative charge. When they are deficit, which is opposite of excess, you expect a positive charge. Then electric current is also the movement of electrons. So all these three are correct. So D is the right answer for this. Thank you. Now let's look at this Jamb past question for physics 2018. Question number 4. Natural radioactivity consists of the emission of A. Alpha particles and beta rays, B. Alpha particles and X rays, C. Alpha particles, beta and gamma rays, D. Y rays and X rays. Now, for us to understand this very well, we need to know the definition of natural radioactivity, and we'll have that natural radioactivity is the spontaneous disintegration. Natural radioactivity is the spontaneous disintegration or splitting. You can call it disintegration or you can call it splitting. Splitting up or breaking down. You can also call it breaking down of the nucleus of a radioactive atom with the emission of alpha particles, beta particles or rays, and gamma radiation. With a great deal of energy. With a great deal of energy when such a radioactive atom is exposed to the atmosphere or buried in the ground. So that is what natural radioactivity is. The spontaneous disintegration, that's the breakdown of radioactive atoms like rhodium and like uranium and all the rest of them, with the emission of alpha, beta and gamma rays. So if you look at this, you see that number C has alpha, beta, this is gamma rays, but it's represented here with G, but this is actually gamma rays. So that makes C the option that has the complete specification of all the particles that are emitted, alpha, beta and gamma rays. Those are the things that are given out or emitted. Those are the emissions during natural radioactivity, which is the spontaneous decay or spontaneous disintegration of the nucleus of a radioactive atom. So C is the right answer, and this is the complete definition of natural radioactivity. Thank you. Yes, let's look at these Jamb past questions, physics 2018. Question number 5. Which of the following does not describe the image formed by a plane mirror? A. Erect. B. Laterally inverted. C. Same distance from mirror as object. D. Magnified. Now, for us to appreciate this question very well, we need to look at the properties of image formed in a plane mirror. So we need to know this. If we know these properties, then it will be easier for us to be able to identify the answer. Now we look at the properties of images formed in a plane mirror, which is the question here, so that we can identify from the options that we have here the one that is not there. Now, the following are their properties. They are: number 1, erect. Number 2, they are laterally inverted. It's one of the properties. 3, they are same size as the object placed in front of it. Placed in front, that is, they are same size as the object. That's the meaning of that. Then 4, they are also same distance as the object in front, or just object. And number 5, they are virtual, that is, they cannot be formed on a photographic screen. They are virtual, that is, cannot be formed on a photographic screen. So all these are characteristics of images formed by a plane mirror. So we can simply see that the option that is not there is D, which is magnified. So images that are formed by a plane mirror, very, very important, they are not magnified, unlike that of concave and convex lenses. For plane mirror, you don't have magnification. So D is the right answer to this, because these are actually the properties of images formed by a plane mirror. They are erect, they are laterally inverted, they are same size as the object and same distance as the object. So, and they are virtual. So those are the properties, and from that, the option that is not there is magnified, D. Thank you. Yes, let's look at this question number 6 for Jamb Physics 2018. What is the resultant resistance of the circuit given above? This is the circuit, and we are told to calculate the resultant resistance of these 3 ohm, 4 ohm, 2 ohm and 2 ohm in this fig 4. Now the options are A, 8 ohms, B, 11 ohm, C, 4 ohm, D, 3.6 ohm. So what is the resultant resistance? Now, for us to be able to do this calculation very well, we need to know the formulas for resultant resistance. If the resistance are in series, the total resultant resistance, or the total resistance, is R1 plus R2 plus R3. Then you continue adding. This is for a series arrangement. Now, if they are in parallel, it's going to be 1 over R total is going to be 1 over R1 plus 1 over R2 plus 1 over R3. So this is for parallel arrangements. So these are the two formulas for calculating. So like these 2 ohm and 2 ohm, they are in parallel, but the 3 ohm, the combination of these two and these are in series. So we're going to find out a way of doing this. So we can do these 2 ohms that are in parallel first. We can add them up together, these 2 ohms and 2 ohms. We can add them up together so that we will now have a direct something. So let's do it. Let's do it because this very figure shows 2 ohms resistor, these 2 ohms resistor, which are in parallel, but they are now combining in series with these 3 ohm and 4 ohm. So therefore the total resistance will be given as shown. So we can now have our R total to be equal to, this one is in series with the both of this and this. So you can just say that you have here 3 ohm, this very 3 ohm, but these two are in parallel. So you can add the two of them together by saying that they are 1 over RT, they are in parallel, and they can be added by saying 1 over 2 plus 1 over 2. So you have this ohm, then plus this one is also in series with the total arrangement. So we have what? 4 ohm. So that's what we're gonna have. Then 1 over 2 plus 1 over 2 is like having 1, because this is half and half is 1. So here we can have 3 ohm plus this thing that is equal to this is just saying half, and inverse of is just saying half plus half, which is 1. Inverse of 1 is still 1. So you have 1 ohm plus this 4 ohm here. So you can simply have how many? 3 plus 1, which is 4, plus another 4, 8. So the answer is simply 8 ohms. Very, very simple. You can also do it one by one by just finding this and this. This and this are in parallel. So you can have 1 over 2 plus 1 over 2, which is 1. Inverse of 1 is still 1. So that you will now have 3 ohms plus 1 ohm, because this and this is 1. Then plus 4 ohm, which will still give you 8 ohms. So the right answer here is 8 ohms. Thank you. So welcome. Let's start with this Jamb past question, physics 2018, question number 7. Which of the following best describes the energy changes which take place when a steam engine drives a generator which lights a lamp? A. Heat to light to sound to kinetic. B. Heat to kinetic to electricity to heat and light. C. Kinetic to light to heat to electricity. D. Electricity to kinetic to heat to light. So what is the answer to this problem? Now, for us to understand this problem, we need to first of all know the first law of thermodynamics. Very, very important. The first law of thermodynamics, or you call it the law of conservation of energy, the law of energy conservation, which basically states that energy can go from one form to the other, but not created nor destroyed. Energy can neither be created nor destroyed. That is the first law of thermodynamics, or laws of conservation of energy. But can neither be created nor destroyed, but can be converted from one form to another. So that is what can happen to energy. Energy can move from being in the form of heat to light, or to sound, or to kinetic, or to any of these forms here. So energy can actually move from one form to another form. But in this situation, what is the movement of the energy? Now let's look at the problem in particular. Which of the following describes the energy that takes place when a steam engine, look at that, a steam engine. So how does a steam engine work? Now let's say you have a container and you have water inside this container. Now you have to apply heating. So this is heating. You apply heat to this water. When you apply heat to this water, what happens? The water gains kinetic energy and turns into steam. So you have kinetic energy being like heating. Immediately after applying this heat on this container, this water will turn into steam. So you know, when a substance moves from liquid to gas, it means that it is gaining kinetic energy. So it gets kinetic energy because of the what? Heat. So you have, after applying heat, you have the water gaining kinetic energy. When it gains kinetic energy, what do you think will happen? If it gains kinetic energy, it is going to use the force of the motion of the water to turn the shaft of a generator in order to produce what? Electricity. So when it turns the shaft of a generator, it produces electricity. So you notice from heat to kinetic to electricity. Now what does this electricity do in this generator? What will it do? It will be able to, if you have a lamp like in your house, your electricity should be able to light up your lamp. You should be able to what? Light up your lamp. And as it's lighting the lamp, when you touch the lamp, you will notice that there is heat in the lamp. So you see the motion here from heat to kinetic to electricity to light and heat. So you see that the option B is the right answer there, because there is from heat, as we have here, you heat the container in order to convert the water to steam. That's what a steam engine does. Then the water gets kinetic energy when it's going from water to steam because of the increase in temperature. So there is kinetic energy. Then the force of this water or this steam in turning the shaft or in working in the generator generates electricity, and this electricity is used to heat and light up your lamp. So option B is the right answer. So option B is the option as the answer. Thank you very much. Welcome. Now let's look at this Jamb past question physics 2018, question number 8. Cathode rays are A. High energy electromagnetic waves, B. Protons, C. Neutrons, D. Streams of electrons. So what are cathode rays? Are they high energy electromagnetic waves, protons, neutrons, or streams of electrons? Now, cathode rays are streams of electrons, and its effects can be observed using a cathode ray tube in a process known as thermionic emission. So for us to understand this question very well, we need to state this fact that actually cathode rays are streams of electrons. That is what cathode rays are, streams of electrons. effect of cathode rays can be observed using what we call a cathode ray tube. So when you check your textbook for cathode ray tube, you're going to see these very cathode ray, how it works, and again, this is the process that actually happens in the cathode ray is what we call thermionic emissions. So whenever there is the application of heat, there is release of some emissions. Thermionic emission simply means ionic emission due to the application of heat. So when you have heat on a filament, you have heat being applied, then there will be emission of some ionic particles, and this time around electrons. So when there is emission of electrons and these electrons move, we have what we call cathode rays. So you're gonna look at this cathode ray tube and see how this motion is done. In your physics textbook, check under ionic emission. We're going to read about cathode rays, and you see that actually cathode rays are actually streams of electrons. That is what cathode rays are, streams of electrons. So that is the answer to this problem. They are not protons, they are not neutrons, but they are streams of electrons. Thank you. Yes, welcome. Let's look at this Jamb past questions physics 2018 question number 9. A narrow beam of white light can be split up into different colors by a glass prism. The correct explanation is that A. White light is an electromagnetic wave. B. The prism has all the colors of the white light. C. Different colors of white light travel with different speeds in glass. D. White light has undergone total internal reflection in the prism. So what is the answer to this problem? Now, for you to understand it, you need to understand some technical terms or phenomenon in white light. And here we're talking about dispersion of white light. What is dispersion of white light? We need to know what dispersion is. For us to understand this, we need to know what refraction, diffraction, internal reflection, all those things. So, but the phenomena that goes with this very particular case is what we call dispersion. So we say that a narrow beam of light. What happens to a narrow beam of white light? Can you tell me what does happen? It can actually be split up. A narrow beam of white light can be split up into different colors. You can do that, and that follows from what we have up here by a glass prism. So if you want to split up a narrow beam of white light, you use what we call glass prism. So why does this happen? This is because, and this will give us the answer to what we are asking, why does a narrow beam of white light split up when passed through a glass prism? It is because different colors of white light, that means in white light there are actually different colors inside this. Different colors of white light travel. These different colors of white light, they move. You will not see them until you pass the white light through a glass prism. They are actually different. There are actually different colors inside the white light, and they move with different speed. So whenever you pass them through a glass prism, you will now see that some of them move in. You will now see that they actually move in different speed, and you will be able to know that there are actually different colors. And of course, with, whenever something is moving with different speed, you can say it is moving with varying, that is also different wavelengths. So you will not notice this until you pass it through a glass prism. Different wavelengths in a gas prism, in a glass prism. So they actually move in a different wavelength, so you'll be able now to see the different colors in the white light. This effect is known as dispersion of white light. This very thing I just explained is known as what we call dispersion of white light. So whenever you're asked what is dispersion of white light, dispersion of white light is actually what happens when a narrow beam of light is split up into different colors because of its passage through a glass prism. And this happens because the different colors in this very white light travel with different speed and of course varying wavelengths. So you can see that the answer from the options is just option C, because here it is written that different colors of white light travel with different speeds in glass. So that is the answer to this, and it is known as dispersion of white light. Dispersion of white light. Thank you. Hello, welcome. Let's look at this question number 10 for Jamb Past Questions Physics 2018. Figure 2, this very figure here, represents a block and tackle pulley system on which an effort of W newtons supports a load of 120 newtons. If the efficiency of the machine is 40%, then the value of W is A, 28 newtons, B, 48 newtons, C, 288 newtons, D, 50 newtons. So what is the value of the W? This is the W here. So having this is the W from the question, this is the W, and this is the load. So this is L. L is equal to 120. So take note of this. L is equal to 120. This is W, which is the effort. So this is the load, L, and it is equal to 120. Effort is W, and you are needed to find out L. Also note from this that we have how many pulley systems. We have 1, 2, 3, 4, 5, 6. So we have 6. So that means that the VR is equal to 6. So take note of these very things before we start the calculation. So from what is given, we have E to be equal to W, which is the effort. This is the effort. E equal to W, and that is what we are told to calculate. We have L, which is load. Load is equal to L, which is equal to 120 Newton is given. So E is equal to effort. We are supposed to know all this. This is basic things in calculations as this. Now, another thing that is given is VR, which we all call velocity ratio. VR, velocity ratio. I want to give us the formula before I start solving. How do you get this? By the number of wheels. Number of wheels. And I just counted the wheels. I have 1, 2, 3, 4, 5, 6. So VR is equal to 6. Now, having all this, we can now put the formula for efficiency, because efficiency is given us here as 40%. So efficiency, we all know in this calculation, is MA all over VR times 100 over 1. So that is what efficiency is. And we all know that MA, mechanical accuracy, is actually equals to load over effort. So with this, we can do this calculation effectively. So having known all this formula, we can now calculate efficiency again. Efficiency is actually equal to MA. MA is L over E, and L is 120 from here, LO is 120 here, all over E. So in place of MA, I'm putting LO over E. And you all know that E, okay, so L over E, so this is L over E, then this all over VR, this is efficiency is equal to MA over VR, and MA is already L over E, which is 120 over E, so what is remaining is VR, so all this all over VR, which is 6, we know that VR is equal to 6, so times 100 over 1. So that is it, and we know that efficiency already is equal to 40%, so we can put 40 here, equal to 40. So what is left for us to make W is to make E the subject of the formula, which is the effort, and we know that E is the same thing as W. So we now have, in essence, 40, which is this 40, is equal to 120 over W. In place of E, now we are putting W because it told us that E is equal to W. The effort is W newtons. So all this all over 6 times 100 over 1. So if you do this calculation by making W the subject of the formula, you get the answer. So if we make W the subject, we have W to be equal to, and cancel out, we have W to be equal to 50 newtons. So W will give us 50 newtons. So the answer is D. W equal to 50 newtons. So how do we make this the subject? We have 40 is equal to 120 over W divided by, so you can say times 1 over 6 because it's divided by 6, times 100 over 1. So if you multiply out, we have 40 is equal to 120 times 100, you have 1,200. Yes, this is 120 times 100, we have 12,000 all over W times 6, which is W6. So when you cross multiply, you have 6 times 40, 40 times 6 times W is equal to 12,000. So make W the subject, have W all over 12,000 all over 40 times 6. So if you cancel out, you get 50. So how do you cancel out? 0 here cancel 0. You have 4 here cancel 12, which will give us 3. So you have 300. So you have 300, 30 into 6 is 5. To 0, 0. So we have 50. So that's how we come about 50 newtons. So the correct answer is D, 50 newtons. Please note the formulas that efficiency is equal to mechanical accuracy over velocity ratio times 100 over 1. This is the formula that we use for this calculation. EFF, efficiency equal to MA over VR times 100 over 1. Now, also note that mechanical accuracy MA is equal to L over E, load over effort. This is the load here, and this is the effort that you're making to carry this load. MA equal to load over effort. Now, note that VR is the same thing as the number of wheels in this pulley system. So these are the formulas in calculating a pulley system. Efficiency is equal to mechanical ratio over velocity ratio, mechanical accuracy over velocity ratio times 100 over 1. Mechanical accuracy is equal to load over effort, and velocity ratio VR is the same as the number of the pulley wheels in the pulley system. So take note. Thank you, and God bless you. Welcome. Let's look at this question number 11 for Jamb Past Questions Physics 2018. The question goes, what type of reaction is represented by the following scheme? We have nuclear X, superscript 2, subscript 1, plus nucleus Y, superscript 2, subscript 1, to form nucleus Z with superscript 3 subscript 2 plus a neutron, superscript 1 subscript 0 plus energy. The options are A, fission reaction, B, fission reaction, C, chain reaction, D, radioactive decay. So how do we go about solving this? Now, for us to be able to handle this well, we have to note that there are two types of radioactivity, or two types of radioactive reaction. And those two types are, one, we have what we call nuclear fission, and number two, we have what we call nuclear fusion. See the two names, fission and fusion. So whenever you hear nuclear fission, you are talking about the splitting, breakup, splitting up of one heavy nucleus. So when you have one heavy nucleus breaking up to form lighter ones, to form a lighter, or to form lighter nucleus, two lighter nucleus, maybe of equal parts, or you can say it is also the splitting into two approximately equal parts, or two approximately equal nucleus. And this breaking is actually with the release of huge amounts of energy, with the release of huge amounts of energy and neutrons. So when this happens, we say that we have nuclear fission. Whenever you have a big nucleus splitting together into smaller ones with the release of energy, we call it nuclear fission. But nuclear fusion is the fusing together, the coming together of lighter nuclei. So when you have two light nuclei coming together, that's smaller nuclei, we call it nuclear fusion. So when they are coming together, we call it fusion. When they are breaking up, we call it fission. So when smaller ones come together to form a heavier nucleus, we call it nuclear fusion. And this also happens with the release of energy. So whenever there is radioactivity, there is always release of great amounts of energy. So this happens with the release of large amounts of energy. Very, very important. So we have nuclear fission or nuclear fusion. So here, when you see fusion reaction, it also simply means nuclear fission, and when you see fission reaction, it means nuclear fission. So which of these explains this? You will see that when you look at this nuclei, this is 2 and here is 2, but they form 3. So you have smaller ones coming together to form big one with energy. Here is 1 and here is 1, and here we have 2. So we have this and this combining to form this. So you can say that this is actually nuclear fusion because they are coming together to form a bigger one. So anytime you want to study this, please, you have to take note of you look at the nucleus that you have on the other side, on the reactant side. If they are smaller, like the case we have here, these ones are smaller. We have 2 and we have 2, but here we have 3. So we have smaller ones forming bigger one with the release of energy. So we call it nuclear fusion. And that's why option A is the right answer. If they are breaking down, had it been this one is having like 1 or half, is lesser, then it will be fission. But when they are coming together to form a bigger something with the release of energy, we call it nuclear fusion. So nuclear fusion, or you call it fusion reaction, that is the answer. Thank you. this question number 12 for Jamb Past Question Physics 2018. The amount of heat needed to raise the temperature of 10 kilogram of copper by 1 Kelvin is its A. Specific heat capacity, B. Latent heat, C. Heat capacity, D. Internal energy. Now, for us to be able to appreciate this question very well, we need to know the definition of these various terms. And we're going to start with number 1, which is specific heat capacity. Now, whenever you hear the word specific, you're considering 1 kilogram. Here we have 10 kilogram, and even we have 1 kilogram. We know we are talking about specific heat. So this definition is still holds true for specific heat, but in this case we're having 1 kg. So specific heat capacity is the amount of heat needed to raise the temperature of 1 kg. It has to be 1 kg of a substance. This time around we have copper, but it could be any substance or any metal by 1 Kelvin. So that is what specific heat capacity is. Now number 2, we look at latent heat. What is latent heat? Latent heat is that amount of heat needed, the amount of heat needed to cause change in state. The amount of heat needed to cause change in state. That is when there is change from solid to liquid or liquid to gas without rise in temperature. So when latent heat is used, there is no rise in temperature. Now number 3, we look at heat capacity. What is heat capacity? Heat capacity is the amount of heat needed to raise the temperature of a given mass. So this is a given mass, 10 kg, it could be 20, it could be 30. So provided the mass is not 1 kg, then we'll call it a given mass of a substance by 1 Kelvin. So that is what heat capacity is. Whereas internal energy is the energy due to the molecular bonding. So internal energy is the energy due to the molecular bonding. So the molecular energy, the positioning of the molecules, that is what causes the internal energy. So from these definitions we can see that C is the right option, because heat capacity is the amount of heat needed to raise the temperature of a given mass, say 10 kg, it could be 20, it could be 30, it could be 100 of copper by 1 Kelvin. But if this mass is 1 kg, then it will be specific heat. So whenever you hear the word specific, we are talking about 1 kg, but once it's more than 1 kg, we'll talk about heat capacity. And that is the answer to the problem. Option C. Thank you. Now let's look at this question number 13 for Jamb Past Questions Physics 2018. The electrochemical equivalent of silver is 0.0012 gram per coulomb. If 36.0 gram of silver is to be deposited by electrolysis on a surface by passing a steady current for 5 minutes, the current must be A. 600 amperes, B. 100 amperes, C 10 amperes, D 1 amperes. Which this should be in capital letter amp, the A's are in capital letter for amperes. Now let us solve this. First of all, for us to be able to solve this, we need to recognize the fact that the electrochemical equivalent of a substance is the amount of the substance mostly in mass deposited by one column of electricity in an electrolytic process. So that very amount is actually represented with the letter Z. Now the relationship between mass deposited and the quantity of electricity is Q times Z, which is the electrochemical equivalent. And we know that Q is equal to current times time, IT. So we can now say that mass deposited is equal to current times time times Z. So with this we can make current the subject of the formula. I, making it the subject, will have M all over TZ. So that is what we are going to be doing to calculate the current. So the current is equal to mass. Mass as we have here is 36 gram, 36 all over T. T is the time. We have T here as 5 minutes. We need to convert it to seconds, so it's going to be 5 times 60. So times Z, which is the electrochemical equivalent, which is 0.0012, 0.0012. So if we solve down, if we press our calculator to solve down, we are going to find out that we have 100 amperes. So, and that is the final answer, B. And this is the B, 100 amperes. This is A, this is 6,000 amperes, this is 10 amperes. The A is in capital letter. So the right option is 100 amperes, because when you cancel out, 6 here is going to give us 6, here is going to give us 10. So if you cancel out, you're going to have 100 amperes, and that is the answer to this problem. Thank you. Welcome. Let's look at this Jamb past questions, physics 2018, question number 14. Shadows and eclipses result from the A. Refraction of light, B. Reflection of light, C. Diffraction of light, D. Rectilinear propagation of light. So which of the following causes the shadows and eclipses? What causes the shadows and eclipses? Is it the refraction of light? Is it reflection of light? Or is it diffraction or rectilinear propagation of light? Now, The right option is rectilinear propagation of light, because all these are caused by the movement of light in a straight path. So whenever you have your light and it moves in a straight path, if something is blocking it, you have what we call shadows and eclipse. And you know that eclipse happens when the sun is at the middle, then with the earth revolving around it, and also the moon revolving around the earth. So whenever the moon is in between the earth, this is the earth and the sun, you have what we call eclipse, which is a special kind of shadow that is being cast on the earth because of the blocking caused by the moon. And this is actually because the sun is emitting light that is traveling in a straight line, and motion of light in a straight line is known as rectilinear propagation of light. So whenever you hear the word rectilinear, it simply means movement of light in a straight line, movement of light in a straight line. And that is why option D is the correct option. So rectilinear propagation of light is the movement of light rays in a straight line. That is what rectilinear propagation. And this rectilinear propagation of light causes so many things, not just the shadows and the eclipse. It is the cause of, number one, shadows. Shadows are caused by rectilinear movement of light in a straight line. Number two, eclipses. Eclipses is as a result of this. Then you also have application like the pinhole camera. If you know about the pinhole camera that you use in physics, it is also due to the rectilinear propagation of light. And finally, we have what we call the ray box. The ray box. All these are possible because of the movement of light in a straight line, which is known as rectilinear propagation of light. So refraction is another property of light, reflection and diffraction. But this and when you talk about reflection, you're talking about when you have a plane mirror and you have the incident ray, then you have the reflected ray. Then when you talk about refraction, you talk about when you have a prism, then you have light coming here, then instead of being reflected, it goes in here and comes out like this. This is the refraction. So we have refraction of light. All these are different motions of light. This is reflection. So these are different motions of light, but the ones that are responsible for the very movement of light that is responsible for shadows, eclipses, pinhole camera effect, and the ray box effect is the movement of light in a straight line, which is also known as rectilinear propagation of light. Thank you. Come, let's look at this Jamb past question physics 2018. Question number 15. Which of the following obeys Ohm's law? Option number A, all metals. B, diode only. C, all electrolytes. D, glass. Now we should always know that whenever you talk about Ohm's law, it has to do with metals. And what is the statement of this Ohm's law? In order for us to get this well, we need to note the statement of this Ohm's law. And what does it state? Ohm's law states that the current passing through a metallic, you see why I say it has to do with metals, passing through a metallic conductor. So Ohm's law has to do with metals. So the current passing through a metallic conductor is directly proportional to the potential difference across its ends. That is the statement of Ohm's law, that the current passing through the metallic conductor is directly proportional to the potential difference across its end. And this law holds true provided that that is for the conductor, its physical components and temperature remains constant. So that is the statement of Ohm's law. In equation form, you can say that the potential difference is directly proportional to the current. And when you remove the proportionality sign, you now put equal to, you introduce a constant, and that constant is known as resistance. So this is the statement of the Ohm's law, that potential difference is directly proportional to current. And when you remove the proportionality sign, you introduce the equal to and introduce a constant. The constant of proportionality here is known as resistance. And you can use this equation to calculate the current, resistance, or potential difference for a conductor. So from the statement of the Ohm's law, which I just stated now, you can see that the Ohm's law has to do with metallic conductors, metals. So from the options, you can see that the most likely is option A, which is all metals. Though I also think that some metals don't actually obey Ohm's law like that, like tungsten that is used for bulb. So the right option here is A, all metals, because in the statement of Ohm's law, we have that Ohm's law states that the current passing through a metallic conductor is directly, whenever you say directly, this is the sign, directly proportional to the potential difference V, provided that the temperature remains constant. And that is that. Thank you. This question number 16 for Jamb past question physics 2018. And the question goes like this: which of the following statements are true of isotopes? I. Isotopes of an element have the same chemical properties because they have the same number of electrons. II. Isotopes of elements are normally separated using physical properties. III. Isotopes of an element have the same number of protons in their nuclei. The options are A, I and II only, B, I and III, C, II and III only, D, I and III. So which is the correct option? Now, for us to be able to appreciate this question very well, we need to know what isotopes are. So what are isotopes? And we know that isotopes are, or is actually an existence. That's what isotope is. The existence of atoms is a phenomenon where atoms exist, and those atoms are of the same existence of atoms of the same atomic number. Atoms of the same atomic number. And whenever you hear the number atomic number, it simply means the number of protons. Atomic number simply means proton number is the same. So when there is this existence of atoms of the same atomic number and the same properties, the only difference between this atom is actually that they differ in their mass numbers. So when you have atoms of the same atomic number but different mass numbers, then you know that the phenomenon known as isotopy is happening. So isotopy is a phenomenon whereby atoms exist in the same atomic number but having different mass number. And whenever you talk about mass number, you are talking about the number of protons, that's the proton number plus the neutron number. So proton number plus neutron number, that is what mass number is. So if you have an atom that has, let's say, 9 protons, 2 of them having 9 protons, but because one is having 10 electrons and the other one is having 12 protons, this one is going to have mass number of 19 and this one is going to have mass number of 20. So you see that their proton number is the same but their neutron number is different. So that is what we call isotopy. And how you notice that the proton number is different is that their mass numbers are going to be different, because mass number is proton number plus neutron number. And note that proton number is always equal to electron number. Why? Because the atom is electrically neutral. So from this we can easily pick out the answer, because I says isotopes of an element have the same chemical properties because they have the same number of electrons. Yeah, because their proton number, like I said, the proton number is equal to electron number. That means they have the same number of isotopes have the same number of electrons. So I is correct. Now, isotopes of elements are normally separated using physical properties. We don't know of this fact, so this cannot be true here. But the you have isotopes of an element have the same number of protons. That is what I said here. So this is also correct in their nuclei. So we have option I and I to be correct. So this B is the right option because I is correct and I is correct. So we are very sure about these two. We are very sure about I for isotopy, and we're also sure about I for isotopy. So if we use elimination method, can easily pick option B as the right option for this, because isotopes are existence, or you can say isotopy is the existence of atoms of the same atomic number, that is proton number, and properties. They have similar properties because of this similar proton number, but they only differ in their mass numbers. They differ greatly in their mass numbers. So that is the end for this. Thank you. Let's look at this Jamb past question. Question number 17 for Physics 2018. In the diagram above, the hanging mass M2, this is the hanging mass M2, is adjusted until M1 is on the verge of sliding. The coefficient of static friction between the mass M1 and the table is option A, M1 over M2, B, M1G over M2, C, M2 over M1, D, M2G over M1. So how do we go about solving this? Question number 17. Now, in order to be able to appreciate this question, we need to understand what coefficient of static friction is. And coefficient of static friction is actually the frictional force F all over the normal force R. So that is what coefficient of static friction is. Then basically, looking at this diagram and looking at the options that we have here, you can simply relate this by saying that U is the force by this M2, which is mass times acceleration due to gravity, all over the force by this M1, also times this acceleration due to gravity. So if you cancel this D and G, you will have U to be equal to M2 over M1, and that is C as being the option and the correct answer for this. So C is the answer. Thank you. Let's look at this question number 18 for Jamb Past Question Physics 2018. Which of the following may be used to explain a mirage? I. Layers of air near the road surface have varying refractive indices in hot weather. I. Road surfaces sometimes become good reflectors in hot weather. I. Light from the sky can be reflected upwards after coming close to the road surface. So we have the following options: A. I and I only. B. I and I only. C. I only. D. I and I. Now, for us to be able to understand this concept very well, we need to know what a mirage is. So how do you explain the concept of mirage? Now you are driving your motor on the road on a sunny day. So you're moving on the road on a sunny day. Then you sitting inside your car, you look down, you're going to be seeing something that looks like a pool of water. But as you're driving closer to that pool of water, you see that it disappears and you find it another place. So this very phenomenon is known as mirage. So if you drive a car often, you find out that you've noticed this once or twice in your lifetime, or as several times as possible. So when you're driving, you see something that looks like a pool of water, and it's not as if it does exist, but it's actually because of the hotness of the weather, because of the reflection of the light rays from the sun. So now, taking this in perspective with what the question is, so what are the options that are likely answers? Now, layers of air near the road surface have varying refractive indices in hot weather. That is true. So I is true. Now, road surface sometimes become more reflectors in hot water. Does something become more reflector after some times and doesn't become in some other times? You see that this I is shaky. But this number three thing, lights from the sky can be reflected upwards after coming close to the road surface. That is reflection, and that is true. So we can easily see that I and I are very true. So with that, I can pick option B as the correct answer. Thank you. Let's look at this question number 19 for Jamb Past Question Physics 2018. In the diagram above, this is the diagram. If the atmospheric or the atmosphere pressure is 760 millimeter, the pressure in the chamber G, this is chamber G, is A 660 millimeters, B 830 millimeters, C 690 millimeters, D 860 millimeters. So how do we go about solving this? There is this general formula that whenever we have a tube of this kind with a chamber, that the right way to do our calculation is that the pressure that this distance is making plus this distance will give us the pressure that this other distance is making plus the distance. So with that, we can say that if we are considering this as pressure 1, this height as pressure 1, we have pressure 1 plus the distance as d1. It will give us what this one is making, pressure 2 plus the distance d2. So with that said, the pressure 1 like we are giving here is the atmospheric pressure, which is 760 millimeters, plus d1 as we can see here is 10, and this 10, if we convert it to millimeter, is going to give us 100 millimeters. So we have 100 millimeter here equal to P2 is what we are looking for, plus D2 is 3. If we convert this to millimeter, we have 30. So this 760 plus 100 is going to give us 860 to be equal to P plus 30. So making P the subject, P is equal to 860 minus 30, which will give us 830 millimeters. And that makes B the correct answer to this using this simple formula. So check it out, and that is how you can come around the answer. Thank you. Look at this question number 20 for Jamb Past Question Physics 2018. Which of the following has the lowest internal resistance when new? A. Leclerc cell, B. Daniel cell, C. Touch battery, D. Accumulator. Now, for us to be able to appreciate this question very well, we need to know, first of all, note what internal resistance is. Whenever you're talking about the batteries or cells, you talk about internal resistance, small letter R, as against the normal resistance, big letter R. So what is internal resistance? We know that internal resistance is the opposition. That is what it is, the opposition given to a voltage source. That opposition that is given to a voltage source is the internal resistance. Now, in order for you to be able to pick out the internal resistance, you're going to ask yourself, which of these cells or which of these batteries or these charge sources produce the highest charge? You find out that that is likely to be the one that has the least internal resistance. And from there, you know that the accumulator is the charge source that produces very high voltage for a very long time. So it's most likely going to be the one that has the least internal resistance. Because Leclerc cell and Daniel cells, they are smaller versions of battery cells, even touch battery. But the accumulator, we know, can be used in this is what you use in big automobiles and in houses. So D is the correct answer for this. Thank you. Let's look at this question number 21 for Jamb Past Question Physics 2008. The pitch of an acoustic device can be increased by A. Decreasing the loudness, B. Increasing the amplitude, C. Increasing the frequency, D. Decreasing the intensity. Now, for us to be able to appreciate this very well, we need to first of all know what a pitch is. But as a point of note, whenever you hear the word pitch, know that it has to do with frequency. Anytime in sound that you hear about pitch, know that it has to do with frequency. Now, what is the pitch of a given sound? We can say that the pitch of any given sound the location of a musical note on a musical scale which can be determined by frequencies of the sound made. So when you want to get a pitch of a sound, it has to be located by taking note of the location of the musical note in a musical scale, and this musical scale is actually determined by the frequencies. So when you're talking about increasing the frequency, increasing the pitch, you are talking about increasing the frequency, and that makes option C to be the right answer. So whenever you have questions relating pitch, know that you are talking about frequency of sound, and if you want to increase the pitch, you have to increase the frequency, and that is the answer to the problem. Thank you. Let's look at this question number 22 for Jamb Past Questions Physics 2018. One of the features of the fission process is that A. It leads to chain reaction. B. Its products are not radioactive. C. Neutrons are not released. D. The sum of the masses of the reactants equals the sum of the masses of the products. Now, for us to be able to appreciate this very well, we need to note that in a nuclear fission, we talk about a nuclei of an atom disintegrating into smaller ones. So we have this big one, let's say having 10 and 2, disintegrating into the ones that have 3, 4, 1, 1, with the release of neutron and energy. So this is what we call a fission reaction. Once you have the atomic number and the mass number here bigger than the ones here, we call it fission. But in a case where we have these smaller ones by this side coming together to form the bigger one by this side, we call it fusion. These are the two types of radioactivity that we have. We have nuclear fission and we have nuclear fusion. So when it's fission, we're talking about the big one splitting into smaller ones. But when the smaller ones come together to form the big one, we call it fusion. So how do you know the smaller one and the big one? By checking their atomic number and mass number. So the reactant side here is bigger than this side. So this is fission, whereas this is fusion. Now, so let's look at this question again. One of the features of fission reaction is that A, it leads to chain reaction. Most of radioactivity reaction leads to chain reaction. So this is a correct option for now until we check all these. Its products are not radioactive. That is not true. Some of the products of radioactivity can also disintegrate more to form even smaller ones. So the product can be radioactive. So this is not true. Neutrons are not released. Neutrons are actually released. So this cannot be true. Now, the sum of the masses of the reactants equals the sum of the masses of the products. The sum of the masses here is not exactly equal to this because there is the release of other particles like neutrons, and there is the formation of energy. So this is not true. It cannot be equal. So from this elimination method, we'll find out that A is the correct answer to this because, like I said, radioactivity leads to chain reaction, and that is the answer for that. And the two types of radioactivity is fission and fusion. And I say that fission process is when there is splitting up to produce smaller ones, whereas fusion is when there is coming together of smaller ones to form bigger ones. Thank you. let's look at these Jamb past questions for physics 2018. Question number 23. The linear expansivity of brass is 2 times 10 to the power minus 5 bar. C, which is Celsius. If the volume of the piece of brass is 15.00 cm cubed at 0 degrees Celsius, what is the volume at 100 degrees Celsius? A. 16.03 cm cubed, B. 15.09 cm cubed, C. 16.00 cm cubed, D. 15.03 cm cubed. Now, for us to be able to appreciate this question, we need to know what linear expansivity formula states, or what cubic expansivity. Now, whenever you're talking about volumes of expansion, we are talking about cubic expansivity or volume expansivity. And what is this expansivity in terms of volume? It is actually change in volume, which is the final volume minus the initial volume, all over final volume over the initial volume is V1, final volume is V2, all over V1 times change in temperature. Now, volume expansivity, you call it cubic or call it volume expansivity, so you can call it any of these. Now, this volume expansivity is also equal to 3 times the linear expansivity. So in case if you are not given the value of your volume expansivity, you can get it by the linear expansivity value that you are given by simply multiplying it by 3. So once you multiply the linear expansivity by 3, you should be able to get the volume expansivity. So we are given the linear expansivity, so we say 3 times the linear expansivity gives us the volume expansivity, and is equal to the final volume minus the initial volume, all over the initial volume times change in temperature. So with that, we can simply solve this because all these are already given. So the linear expansivity is already given as this, so I can say that this is equal to 3 times linear expansivity, which is 2 times 10 to the power minus 5, equal to the final volume, which is what we are looking for, we don't have it, minus the initial volume, which we are given as 15 cm cubed. So I'm going to write 15 here, all over the initial volume, which is also 15, times change in temperature. Change in temperature is, we have 100 minus 0, which is also 100. So the change in temperature here is 100 minus 0. So if you solve out and make V the subject of the formula, we are going to find out that V2 is going to be equal to 15.09. So that is the answer to this. So B is the correct option. So how can we solve this down to get this? So having this can give us 6 times 10 to the power minus 5, that is 3 times 2 times 10 to the power minus 5, gives us this, equal to V2 minus 15 all over 100 minus 0 is 100. 100 times 15 is 1500. So when you cross multiply, you're going to have V2 minus 15 is equal to 6 times 10 to the power minus 5 times 1500. That is 1500. So if you multiply this out and you make V the subject, so we're going to have V2 is equal to 6 times 10 to the power minus 5 times 1500, all these plus 15. That is when this 15 goes to this side. So if you multiply this out and add it up to this, you will be able to get 15.09, because this times this is going to give us 0.9. So plus 15 is going to give us 15 plus 0.09, and that is the correct answer to this. Thank you. Tclassified.com. Let's look at this Jamb Past Question Physics 2018. Question number 23. A lead bullet of mass 0.05 kilogram is fired with a velocity of 200 meters per second into a lead block of mass 0.95 kilogram. Given that the lead block can move freely, the final kinetic energy after impact is A. 150 joules, B. 100 joules, C. 50 joules, D. 200 joules. Now, for us to be able to appreciate this question very well, we need to understand the formula of conservation of energy and momentum when there is an impact due to firing. Now, whenever you hear impact due to firing, you're gonna be able to note that you'll be having the initial mass of this lead bullet multiplied by its velocity plus the mass of this block onto which it is making impact, m2, multiplied by the velocity before the impact. Now, after there is an impact, you're not going to have the two masses m1 plus m2. Now the masses are together, they are now moving with one single velocity v. So this is the right expression to solve this. This is the bullet and this is the block. So this bullet goes into this block to form a bullet and a block together, moving now. So this is moving, making this impact to form this. So this is what equation that we have, and from this equation we can calculate this final velocity. With this final velocity we can now calculate the final kinetic energy to be equal to half mv squared. So this final velocity, we need it to do this calculation. We know these initial velocities and masses, but we don't know this final velocity. So that is what we need to calculate. Once we calculate it, we can put it in this formula for kinetic energy to find out our kinetic energy, and that is what we are going to be doing. So make this v the subject of the formula. We have v to be equal to everything here. We have m1 u1 plus m2 u2 all over m1 plus m2. So that is v. So with that we can say that our v is equal to m1 is what, 0.05 times u1 is what, 200. We are given initial mass is 0.05. this is the initial velocity for that. Then plus m2 is what, 0.09. this is our m2 here, 0.09 times this bullet went into this block. This block was not moving initially, so the u2 is 0. So all over m1 plus m2. m1 is what, 0.05 plus m2 0.09. I mean 0.95. So if we solve this out, we are going to be getting 10. That's what we'll get, because this times this, this will go 1 2 to cancel these 2, so that we have 2 times 5, which is 10, plus this times 0 will give us 0, so we have 0 here, all over 0.05 plus 0.95 is 1. So we have 10 plus 0, which is what, 10 over 1, which is 10. So v is equal to 10. From this calculation, our v is equal to 10 meter per second. So having v as 10 meter per second, we can now calculate ke, which is kinetic energy, which is given as half m. The m is the mass, the total mass, which is 0.05 plus 0.95, half m times v square, and v is what, 10 to power 2. So v is 10, so square is 2. So here we have 0.05 plus 0.95, which is 1. So 1 is what we are going to do. So we are still going to have half times 1. So we have half times 1 times 10 to power 2. and 10 to the power 2 is what? 100. So we simply have this is equal to 100 all over 2, because 1 times 1 is 1, 1 times 10 to the power 200. So this is 100 over 2, giving us the final answer as 50 joules, and C is the right option for this, which is 50 joules. So you can see how we came about this by quoting this initial formula for impact. Whenever there is collision and we have one thing colliding with the other with their initial velocities and their masses to form this final velocity when they are now together. So if you make this V the subject of the formula, you get, using the values we have, noting that the velocity of the second, the lead block is 0 because it's not moving, we'll get V as 10. So if we put it in this equation for kinetic energy, which is half mv squared, we'll get kinetic energy as 50 joules, which is the answer. Thank you. Let's look at this Jamb past question physics 2018. Question number 25. In a series RLC circuit at resonance, the voltages across the resistor and the inductor are 30 volts and 40 volts respectively. What is the voltage across the capacitor? Option A, 30 volts, B, 70 volts, C, 50 volts, D, 40 volts. Now, for us to be able to appreciate this effectively, we need to know what resonance is, so that we will know what resonance in a series RLC circuit is. What is the significance of resonance in a series RLC circuit? Now, we can confidently say that resonance occurs in a series circuit when the supply frequency, whenever the supply frequency causes the voltages across L and C, that is inductance and capacitance, to be equal and opposite in phase. So whenever the voltage across the inductance, this is known as the inductance L, whenever the voltage across the inductance and the capacitance, or the inductor and the capacitor, is equal, we call it resonance. That is happening in a series circuit, and this is a series RLC circuit. So for there to be resonance, since we are saying that resonance is happening, it simply means that the voltage in the inductor, here this is the inductor, the voltage here is 40, is the same as that of the voltage of the capacitor. So the voltage of the capacitor is supposed to be 40 as well. So D is the right option as the answer. So whenever there is resonance, whenever there is this phenomenon called resonance, that means that the voltage across the capacitor and that across the inductor should be the same. They should be equal. So since the voltage on the inductor is 40, that of the capacitor is also 40. So that makes D the correct answer. So this is the kind of circuit that we're talking about. You have the capacitor, it's in series with the resistor, and this is the capacitor, this is the resistor, this is the inductor. So the voltage in the inductor, if it is V1, then the voltage in the capacitor is going to be V1 too. So in this case, we say that there is what? Resonance. So resonance occurs when the supply frequency causes the voltage across both the inductor and the capacitor to be equal, and in this case it is 40, and that is the answer. Then at resonance we have what we call minimum impedance. It's also good that you note that at resonance we have minimum impedance. Minimum impedance at resonance. So that is the answer, is 40, because the voltage at the inductor is also 40. So at resonance the voltage at the inductor and at the capacitor is the same, so it's 40, and that is the answer. Thank you. Let's look at this Jamb past question, physics 2018, question number 26. If the fraction of atoms of a radioactive material left after 120 years is 1/64, what is the half-life of the material? A. 20 years, B. 10 years, C. 2 years, D. 24 years. Now, for us to be able to appreciate this question effectively, we need to first of all know what half-life is. And what is half-life? Now, half-life is the time required for a quantity to reduce to half of its initial value whenever there is radioactivity or in nuclear physics. So half-life, represented as T half, is the time required, that very time required for a quantity, for a given mass or quantity to reduce to half, of its initial, half of its initial value. So that is half-life. The time, half-life, whenever you had half-life, we're talking about time. The time required for a quantity to reduce to half of its initial. So let's say the initial value is 20. That time it will take for it to become 10. From 20 gram to 10 gram. That time is known as the half-life. So now, how do we solve this given the number of years taken and the fraction of the atom remaining after these years? Now, for us to be able to effectively solve this, we need to note the movement from the first movement to half, which is the first movement. Now if you're halving again, you're going to have 1/4, which is the second movement. If you're halving again for the third movement, you're going to have 1/8. And if you're halving again for the fourth movement, you're going to have 1/16. And if you're halving again for the fifth movement, you're going to have 1/32. And finally you're having again for the sixth movement, you're going to have 1/64. And 1/64 is actually what is given here. So how many movements got you to 1/64? You have 1, 2, 3, 4, 5, 6 movements. So now, having that, you can see that half-life is equal to the total time all over the stages. That is the number of movements taken, and the total time is 120 years. All over number of stages is 6. 120 over 6 will give us 20. So the answer is 20 years, and that is how you solve these. Thank you. Welcome. Let's look at this Jamb past question, Physics 2018, question number 27. In the diagram above, which of the simple pendula will resonate with P when set into oscillation? A. U, B. T, C. R and T, D. Q and R. So this is the diagram showing P. You can see P, pendulum P and pendulum T having the same length. You can see Q, you can see R, you can see S, you can see U. So which of the simple pendula will resonate with P when set into oscillation? You can see that P and T are having the same length, so it's likely that T is the answer to the problem, and that makes option B the right answer to this problem. But before I arrived at this answer, it is pertinent that we know what resonance is whenever you're talking about simple pendulum. What is resonance when you're talking about simple pendulum? Resonance is that very condition when a body is made to vibrate. Whenever you make a body to vibrate on its own natural frequency, then you're talking about frequency, you're talking about resonance. Whenever you make a body to vibrate on its own natural frequency by an external vibrating body, by another body that is vibrating, by an external vibrating body, then you have resonance. So from the figure of this pendulum, you can easily see that P is, when it's vibrating, it's going to impart resonance on T because both of them are having the same length. So it's likely that T will vibrate on its own natural frequency because of the vibration of P. So T is going to vibrate on its own natural frequency because of the vibration of P, and that is why B is the answer, because it's going to make T to resonate. P is going to make T to resonate, and that is the answer to the problem. Thank you. Come, let's look at this question number 28 for Jamb past questions, Physics 2018. The time rate of loss of heat by a body is proportional to the A. Temperature of its surroundings, B. Temperature of the body, C. Difference in temperature between the body and its surroundings, D. Ratio of the temperature of the body to that of its surroundings. Now we need to understand what loss of heat is all about. So let's say we have this body and it's losing heat to the surrounding. Now what will ensure that there is loss of heat from this body having temperature T1 to the surrounding having temperature T2 is what we call temperature gradient. Change in temperature, that is temperature gradient. That is difference between temperature of the body and that of the surrounding. That difference, that's what ensures loss of heat, and that makes C the right answer to this. It is not just the temperature of the body. If the temperature of the body is 1000 and the temperature of the surrounding is 1000, there will be no loss of heat because there is no temperature gradient. So if you have 1000 here and you have 1000 here, there will be no loss. Movement is only occurring when there is temperature gradient. If the temperature here is 10 and this one is 20, there will be movement. If it is 30 here and this one is 5, there will be movement. So there has to be difference in temperature, and that is what C is all about. It is not T2 over T1, which is what D is talking about. It is not the magnitude of the body temperature or the magnitude of the temperature of the surrounding, because if the magnitude is so large and but it's equal, then there will be no movement. So what actually causes loss of heat or movement of heat in and out of the body is the temperature difference. Once there is a temperature difference between T1 and T2, we have what we call temperature gradient, which allows for heat loss or even heat gain. So what we'll do, this is what we call temperature gradient, and temperature gradient is actually the difference in temperature between the body and the surrounding. So you can say that this is T body and this is T surrounding. You can say that this is T body and this is T surrounding. Once there is difference between these two, once one could be 1000 and the other one could be 20, then you will talk about what we call temperature gradient. So C is the right answer to these. Thank you. Look at this Jamb past question, physics 2018, question number 29. A positively charged rod X is brought near an uncharged metal sphere Y and is then tossed by a finger with X still in place. When the finger is removed, the result is that Y has A. No charge and a zero potential, B. A positive charge and a zero potential, C. A negative charge and a positive potential, D. Negative charge and a negative potential. So how do we go about solving this? Now, before we can be able to appreciate this question effectively, we need to understand what is called electrostatic induction, or charging via electrostatic induction, or charging via physical touching. Now the act of charging a neutral body by placing a charged body near it is known as electrostatic induction. So very importantly, we need to understand what electrostatic induction is, so that you can be able to appreciate this question very well. And electrostatic induction is the act of charging a neutral body by placing a charged body near it. So when you charge a neutral body by placing a charged body near it, we'll call it electrostatic induction. Now, in this very instance, we are actually looking at you having a rod that is positively charged. This rod is positively charged and is brought near a metal sphere that is uncharged. This metal sphere is not charged, it's neutral, but then it is touched by a finger with this very X still in place. This is X, this is Y. So when the finger is now removed, when you now remove this your finger, what do you expect to be on this very Y? On this very Y, you expect to have negative charge and a negative potential, and that makes the right option for these. Thank you. Welcome. Let's look at this Jamb past question, physics 2080, question number 30. Electrical appliances in homes are normally earthed so that a person touching the appliances is safe from electric shock, B. Both the AC and DC sources can be used. C. The appliances are maintained at a higher PD, that is potential difference, than the earth. D. The appliances are maintained at a lower PD than the earth. Now, wherever you see AC simply means alternating current and DC means direct current. So what is the answer to this very problem? Why do you earth in homes? Why do you earth? It is very clear and common sense that when we earth, we actually earth because we don't want anybody touching the appliances to have electric shock. We want them to be safe from electric shock. That is actually the reason why we do earthing. So whenever you hear the word earthing, earthing is done in order to prevent electric shock. So you do earthing in wiring in order to do what? Prevent electric shock. That is the sole essence of earthing, to prevent electric shock. And that makes option number A, a person touching the appliances is safe from electric shock, the right answer for this. You don't earth because both the AC and DC sources can be used. You don't earth because the appliances are maintained at higher potential difference than the earth. And you don't earth because the appliances are maintained at lower potential difference than the earth. The sole reason of earthing is so that a person touching the appliances is safe from electric shock. So earthing prevents electric shock. It's a special thing that you do in electrical wiring in order to prevent electric shock, and that makes A the answer to this problem. Thank you. Let's look at this Jamb past question for physics 2018, question number 31. The process whereby a liquid turns spontaneously into vapor is called A. Regelation, B. Evaporation, C. Boiling, D. Sublimation. So now, what is the process whereby a liquid turns spontaneously into vapor? Now, for us to get it into context, I'm going to be defining each of the following words that we have. Number one is regelation. What is regelation? Regelation is a phenomenon of melting under pressure. So when there is melting under pressure, we call it regelation. And not just melting, there is also refreezing. So when there is melting and refreezing under pressure, whenever the pressure is reduced. So regelation happens due to pressure, and it happens when pressure is reduced. There is what we call melting and refreezing. That is what regelation is. Then evaporation is actually the spontaneous turning of liquid into vapor, which is this definition. That's the definition of evaporation. Whereas boiling is what happens at a particular temperature. Boiling happens at a particular temperature. For water it is 100 degrees Celsius, and here also in boiling, liquid also turns into vapor, but happening at a particular temperature, unlike in evaporation, whereby we have the spontaneous turning of liquid into vapor. Now, sublimation is when a solid, instead of going through a liquid before a gas, goes straight into a gas. So if you have solid phase going straight into gaseous phase, then we'll call it sublimation. So from all this definition, we can see that B is the right answer for this. Evaporation is a process whereby a liquid turns spontaneously into vapor. Thank you. welcome. Let's look at these Jamb past questions, Physics 2018, question number 32. Which of the following diagrams represent correctly an NPN transistor? Which of the following diagrams represent an NPN transistor? Is it A, as is drawn here, or B, C, or D? Now, for us to be able to appreciate this very well, we need to make a sketch of the diagram of NPN transistor. Now, the NPN transistor has the following diagram. You have this, and you have this, then you have this, then all of it encircled. Then here you have your A, B, and C. So this is the diagram of NPN transistor. So which of the following is very close to what we have here? This is actually E. So you can see that the major difference in all these is this movement going from C up, and that is what we have here. There's actually a movement here going from C up. We have B, we have E. So this makes D the answer. For this number C, we have the movement this side. For this, you have it this side, but going in opposite direction. Also here, you have it this side. So D is the right answer from the sketch that is done here, and that is why we picked option D, because this is the diagram of NPN transistor. Thank you. Hello, welcome. Let's look at these Jamb past questions, Physics 2018, question 33. The difference observed in solids, liquids, and gases may be accounted for by A, their relative masses, B, their melting points, C, the spacing and forces acting between the molecules, D, the different molecules in each of them. Now, for us to be able to appreciate this very well, we need to know about the kinetic theory of matter. We need to know about the what? Kinetic theory of matter, which actually states that matter is made up of small particles. So if we have solid, we have these particles, they are more closely packed together, making very less movement. Then if you have a liquid, there is more space in between them, so the intermolecular force is holding them is smaller. It's not as so tight as that of solid. Now if you have gases, they are widely dispersed with much spacing between them and lesser forces between the molecules. So this is where we have what we call solid, and here we have liquid, and here we have gases. So you see that their behavior is a function of number one, the space in between them, then number two, the intermolecular forces between them. So we have the spaces and the spacing and the forces. So this makes option C the right option for these. So what determines the difference in the behavior of solid, liquid, and gases is the intermolecular forces and the spacing between them, and that is why there is lesser space between the molecules of the solid. There is much better space here in liquid, and even much better space in gases. Then the molecular forces here are very strong, holding them together, preventing much movement. Here it is lesser, there is movement, and here it is even lesser, making there to be dispersed random motion. So C is the correct answer for these. Thank you. Let's look at this Jamb past question physics 2018, question number 34. Convex mirrors are used as driving mirrors because images formed are A. Erect, virtual and diminished, B. Erect, real and diminished, C. Erect, virtual and magnified, D. Inverted, virtual and diminished. Now you find out that convex mirrors are the type of mirrors that you use in your car as driving mirrors. So why is it that we use convex mirrors instead of concave mirrors? Now you have your car and you're driving your car. You have your mirror here that enables you to see somebody that is behind you. So when you look at the picture of this person behind you inside the mirror, you're going to find out that it will be erect. The way it's standing, that's the way you're going to see it is erect. But this time around it is diminished because it's smaller. Diminution simply means smaller. This is bigger than this. This is the image. This is the real object. So it is diminished because it is now smaller. It is erect because it is standing, the head is still up and the head is up here. Then it is virtual. Most of the images formed by mirrors are virtual. So now you have A, having all the properties of images formed by a convex mirror. The B has real, which makes it not the answer. The C has magnified. You can see that it is diminished. This is bigger than what we have here. This one is bigger. This object is bigger than the image, so it is not magnified, it is diminished. Inverted is when we have something like this, which is not the case. It is still standing tall. So this inverted makes this not to be the answer. This magnified makes this not to be the answer. This real make this not to be the answer. So the right option is A. Image formed by convex mirrors are erect, virtual and diminished, and A is the answer. Thank you. Let's look at this Jamb past question physics 2018, question number 35. Musical instruments playing the same notes can be distinguished from one another owing to the difference in their A. Quality, B. Pitch, C. Intensity, D. Loudness. Now, for us to properly appreciate this very question, we need to understand these different perception of sound or qualities of sound. This different perception of sound, that is how you perceive your sound. The quality, which has another name as timbre, has a lot to do with what you can use to distinguish sound from different instruments. So if there are different instruments, you can easily identify them by using their quality or the timbre. The frequency has something to do with the frequency, the pitch has something to do with the frequency of the sound produced. and loudness has to do with the amplitude on how loud or soft a sound is. The intensity has to do with the intensity of the sound coming out. So when you talk about differentiating different instruments, different musical instruments, differentiating them, we talk about the quality of the sound coming from them, which we also call the timbre, because this is the factor that differentiates the same musical notes from different musical instruments, their quality or their timbre. So A is the right option to this. And loudness is only talking about how loud or soft a sound is, and it relates to the total number of auditory nerve simulations over the short cyclic time period, most likely over the duration of theta wave cycle. But timbre or quality is actually what differentiates sounds of similar notes but from different instruments, and that makes A the answer to the question. Thank you. Let's look at this question number 36 for Jamb Past Question Physics 2018. In the diagram above, if the south poles of two magnets stroke a steel bar, this is the steel bar, the polarities at T and V will respectively be A, north and south, B, south and south, C, north and north, D, south and south. Now looking at the diagram, this is the steel bar and these are two magnets, and you can see that the pole that is being used to do the striking is SS. So when you use S to strike, you produce at this end north, which is N. So it's expected that T and V will have polarity of north and north because we are using S and S to do the stroking. So that is what you do, that is what we have because of the principle of like charges and unlike charges. So once you're having south south, you're supposed to have north north at this pole, and this is one of the ways that you can use to to magnetize a steel bar. So since we have south south here, we're going to have north north here, and that is the polarity, and that makes C the right option, because since we are having south south here, we are supposed to have north north here, and that is what you get when you look at magnetization. If you want to magnetization, when you want to magnetize a steel bar, if you want to make a steel bar to become a magnet, you have to do this form of double stroking. And when you do that, if you have SS here, you're going to have NN here, and that is why we have north and north. You can see that this is south and south. Has it been this is north, south and north, then you might be having different things, but you are supposed to have the same thing because you're having the same here as well. And that makes C the answer to this problem. Thank you. Let's look at this Jamb Past Question Physics 2018, question number 37. In homes, electrical appliances and lamps are connected in parallel because A, less current will be used, B, less voltage will be used, C, parallel connection does not heat up the wires, D, series connection uses high voltage. Now, for us to appreciate this, we need to understand what parallel connection is basically. Now we have your voltage source bringing in voltage across these loads. So we have the first load here, we have the second load, then you have the third load. So this is what we call parallel connection. We have the same voltage across these ends but having different currents depending on the load. So that is what we call parallel connection. The voltage across all of them is the same voltage across the terminals, but depending on the R, which is the load, you're having the different currents. So that is what we have in a parallel connection. And in parallel connection, voltage remains the same and the current divides for each. That is one property of a parallel connection, so that 220 volts is there for all of them, providing the current required to take these loads. Now, if one device is not working, like in this arrangement, if this device is bad, these other ones will continue to work. That's why parallel connection is very okay. Unlike if you have a series connection, this is called a series connection with the different loads. You find out that if this one is bad, then there's no current cannot flow past this to work on these ones. So you find out that many of the electrical appliances and lamps are done with this very parallel connection, because if this one is not working, there's still a path to the circuit across like this and like this. So parallel connection is always good. But from this option, we're having less current will be used. Is that true? I don't think this is close. Less voltage will be used. Will there actually be less voltage used since the voltage is just the same? Okay, let's be considering this. Parallel connection does not heat up wires. I don't think this is a nice option from our explanation. Series connection uses high voltage. Now, if the voltage determines the current, so if each of them is going to be having different voltage, you're going to find out that you might be having high voltage. It will use high voltage because you need voltage to transmit current from here to here, then another voltage here. So D is the most likely answer to this problem, and that is the answer for our problem. Thank you. Look at this question number 38 for Jamb Past Question Physics 2018. An object moves in a circular path of radius 0.5 meters with a speed of 1 meter per second. What is the angular velocity? A. 8 rad per second. B. 4 rad per second. D. 1 rad per second. C. 1 rad per second. D. 2 rad per second. So how do we go about solving this? What is the angular velocity given the linear speed? This is the linear speed or linear velocity, and this is the radius. So what formula relates angular velocity to radius and speed? That is what we're going to use. So now we need to state the relationship between linear velocity, this is the linear velocity, this speed given here, and angular velocity. So once we have that relationship, then it solves the problem. And this relationship is that linear velocity is equal to angular velocity times radius. That is the relationship between linear velocity and angular velocity. So if you make w the subject, which is angular velocity, you will now have making this the subject, you now have linear velocity over radius. So that will give us linear velocity as given here is 1, all over radius is what, 0.5. 1 divided by 0.5 is gonna give us 2. So the answer is 2 rad per second, and that is option D, 2 rad per second. Thank you. Look at this question number 39 for Jamb Past Questions Physics 2018. What effort will a machine of efficiency 90% apply to lift a load of 180 newtons if its effort arm is twice as long as the load arm? A. 100 newton, B. 90 newton, C. 80 newton, D. 120 newton. Now, for us to be able to appreciate this, whenever you hear the word efficiency together with the word load having their values, then you know that you're going to use the general formula for efficiency for a pulley system, which is efficiency is equal to mechanical accuracy MA all over velocity ratio VR times 100 over 1, which you can also write as, because you know that MA is the same thing as load over effort, all over VR, which is velocity ratio, is also equal to distance caused by the effort all over distance caused by the load, all times 100 over 1. So this is the same as this. So we're going to use the one that is more effective in solving our problems. So using this, we have efficiency of 90%, which we have 90 is equal to, what is the value of the load? The value of the load is given as 180. So in place of this L load, I put 180 all over effort is what we are looking for. E, we don't know. So all this all over DE. What is DE? What is the distance caused by the effort? We say that the effort arm is what, twice that of the load. So if the effort is 2, that of the load is gonna be 1, 2 over 1. So all these times 100 over 1. So make your E the subject of the formula and the problem is solved. So if I take this 100 over to this place, I'll have 90 over 100, so that I will not have anything here again. So I'll try to make my E the subject, and if I take this 2 over 1 over to here, I'll have 2 times 90 all over 100 equal to 180 over E. So finally, making E the subject, I'm going to have that E is equal to, you cross multiply, it's going to give us 180 times 100 all over 2 times 90. So if I say 0 divides 0 here, then I have 9 here into 18 will give us 2 0. Then I have 2 into 2 will give me 1 0. So I have 10 times 10, which will give me 100 Newton. So my answer is 100 Newton, and that is option A. That is the answer. So what you need to do is to just quote the equation for efficiency, which is mechanical accuracy over VR times 100 over 1, and noting that mechanical accuracy is what, L over E, that's load over effort, all over VR. Velocity ratio is the same thing as distance distance by the effort all over distance by the load, and that distance is the arm as given here, and they told you that the effort is twice the load, that is 2 times the load, that's 2 over 1. So make E the subject of the formula, you get 100, and that is the answer. Thank you. Let's look at this question number 40, the last question for physics, Jamb Pass question 2018. Calculate the effective capacitance of the circuit above. This is the circuit with capacitors in parallel with capacitance 2 microfarad, another 2 microfarad and another 2 microfarad connected in series to 1 2 microfarad and 1 3 microfarad. So that is what we have. So these are in parallel, these three are in parallel. These 2 microfarad is in parallel with these 2 microfarad, also in parallel with these 2 microfarad, whereas these ones is in series with them. So we have 3 microfarad in series with the totality of these 3 plus this other 2 microfarad. So how do you calculate? Now, capacitance in parallel, the total capacitance in parallel is calculated by saying C total is equal to C1 plus C2 plus C3. That is for parallel. Whereas for series calculation, we have C total, 1 over C total is equal to 1 over C1 plus 1 over C2 plus 1 over C3. So you continue to add this one, you continue to add too. So if it is in parallel, it has to be just normal, but if it's in series, you add up the reciprocals. So since this and this are in parallel, we're going to have the total of these 3 is going to be C total is equal to C1, which is 2 microfarad plus C2. This is C1, this is C2, this is C3. C2 is also 2, C3 is also 2, which will give us 6 microfarad. So since you have everything here to be the same thing as 6 microfarad, then you have these 3 in parallel. This is in parallel with this and in parallel with this because they are just connected like this, unlike this one that are having points which are parallel. This is in series, this one is in series with this and in series with this. So for series calculation, 1 over CT is equal to 1 over C1. C1 in this case is 2 plus 1 over C2. C2 in this case is 6 plus 1 over C3. C3 in this case is 3. So this is what we have as our distance. So if we take the LCM of 2, 6 and 3, which will be 6. 6 divided by 2 is 3 times 1, we have 3, plus 6 divided by 6 is 1. 1 times 1, 1, plus 6 divided by 3 is 2 times 1, 2. So we have 3 plus 1 plus 2. 3 plus 1 is 4. 4 plus 2 is 6. So we have 6 over 6. That is 1 over CT is equal to 6 over 6. And 6 over 6 is the same thing as 1. And reciprocal of 1, making CT the subject, CT is also equal to 1. So the answer is D, 1. So first of all, you have to understand the formula for capacitance in parallel, which is just normal addition, and that of series, which is addition of the reciprocals, where the total is also the reciprocal. That's 1 over CT. So D is the answer to this. Thank you.